task. The orange circle represents the running task, while the gray circles represent the pending task. As you can see here, a double parallel approach, inter-parallelism approach, so we have many tasks running in parallel. Intra-parallelism approach, because each task exploits MPI in order to perform the execution. This is another example of a workflow we use in the Ophidia project. Ophidia is the main object of Ophidia is to build a cross-border operational fire danger prevention infrastructure. It's an Interreg project between Italy and Greece, and this is the workflow we implemented in order to compute the fire danger indexes, free fire danger indexes. As you can see, it's a very complex workflow with many tasks which work run in parallel. More or less, we have 150 tasks in total. And as you can see, you can use also some intermediate output from some particular chain. This is particular output from particular chain. This is a snapshot in a certain moment of the execution of the fire danger analysis. So, as I said at the beginning, we provide also programmatic access through Sci-GaIA, but also through the Pyophidia class. So the Pyophidia provides a Python interface that commands to the Ophidia server and to retrieve and deserialize the results. We implemented two classes, a client class to connect to the server, to navigate into the Ophidia file system, to submit workflows, manage sessions, and so on. And a cube class to manipulate cubes, reduce subset, operation between cubes, record Python, and so on. And to get information on cubes, schema, dimensions, metadata, and so on. So, documentation, you can find all the information on Ophidia on our website, ophidia.cncc.it. On ophidia.cncc.it you will find all the information concerning overview of the Ophidia main feature, a quick start guide, a user guide, administration guide, and also a development guide if you want to develop your operators or your primitives. So this is an example of the Ophidia operators manual, the list of all the operators, and a brief explanation. And this is the IP page, Ophidia 1.2.1. We have also a YouTube channel, Ophidia Big Data, where you can find many tutorials, many videos, and examples. So, concluding, Ophidia is a big data leading framework for science. It exploits an OLAP approach for big data and multi-dimensional data model. We implemented many use cases for data analysis in different contexts and domains. It provides access via command line interface and API, programmatic access via C and Python APIs. We use Ophidia in many different scenarios. For example, in Brazil, with C and Indigo. The first official release is available from February of 2016 on GitHub. This is our useful resources, the website, where you can find also the documentation. The Ophidia code is available on GitHub under GPI license. You can download also the RPM in order to store your software X6 machine on the stack of the FIDIA software. But also a virtual machine image without the stack already stored inside in OVA format. So, thank you very much. This concludes my first part of the presentation. If you have questions before I move to the second part.
FIDIA is standalone, right? It doesn't rely on like a Hadoop backend or.
No, yes, it's standalone.
But it seems to re-implement a lot of the ideas of a Spark cluster or a Hadoop cluster. I mean, can you maybe like comment on the similarities?
Actually, there is some differences between other tools as Spark, Hadoop, and so on. First of all, we managing principally structured data. I want to say that similar frameworks are something like SciDB or Rastaman,
right,
which are able to manage data in array form using also a partitioning of the data as of FIDIA. But with respect to these tools, this framework as SciDB or Rastaman, we rely also on an API approach in order to submit the query to the server. And also we are able to manage a different kind of storage. For example, parallel storage as GPFS, IBM GPFS, or standalone local disk storage. So,
sorry, we're going to start with the demo part.
sorry?
You have to move the camera to record your screen.
No,
No?
no, it's the second part of the presentation, it's another presentation.
Okay, but it's not a demo part of the
No.
presentation.
So, now I want to show you some information about the terminal, the FIDIA terminal we developed at CMCC. It is a presentation much more user-oriented, so I'll show you information about the commands you can use in order to interact with the server and the software stack deployed on your machine using the FIDIA. So, as I said in my previous presentation, FIDIA exploits a very complex architecture formed by many layers. So in order to hide this complexity to the user, we want to find an effective way to interact with FIDIA without making the user scared of its complexity. So the solution is to develop the FIDIA terminal, that is a command interpreter with no guide, like Bash, serves as a client for the FIDIA framework. Specifically, it interacts with the server, exchanging JSON message inside SOAP request. So, as I said before, the FIDIA terminal is a commands interpreter with no GUI, like the Bash shell. It's a client for the FIDIA framework. It simplifies client-server interaction within the FIDIA framework, making it easier to take advantage of all FIDIA operators. It can manage history for the user. It offers also documentation feature, specific environment variables, and commands and so on. It is easy to install and it's simple enough for a novice and at the same time powerful enough for an expert user. This is a basic use case of the utilization of the Ophelia terminal. So a client starts the terminal with or without login parameters. Then it can launch commands. Commands could be executed directly on the client or are sent to the server when the output are ready. When the outputs are ready, these outputs are sent back to the user. So, if you want to enter in the Ophelia terminal, you have to use this statement of phterm -u with your username, -p with your password, -H with your server host, IP of the server host, -P with the related port to connect to. You can also launch directly a phterm command without specifying any of these parameters, because you can rely on shell variables or ph user or ph password, so you can define these variables inside your shell environment in order to avoid to type all these parameters. You can also execute a command without entering in the phterm environment with the -e parameter. So we developed a virtual file system in order to store, to manage all the cube belonging of each user. So you can define, create your folders. Project folders, you can create your containers, which are able to manage cubes with the same grid, with the same structure, with the same dimensions. Inside each containers, we have our data cubes. So concerning the phterm environment, we can distinguish between predefined variables and predefined commands. Predefined variables are related to the core prompt, username, password, as I said before, server address and server port, and so on. Predefined commands are to get the description of a command or variable using GL, history, manage the history of commands, and list the environment variables, and so on. So, if you want to launch, to submit an operator to the server, you can use this kind of statement. So, OPH operator, certain operator you want to use, with a list of parameters separated by semicolon. So, put the operator on the left, for example, OPH list, and the sequence of arguments passed to the operator. If you are sure, you can use the manual, that is another operator, OPH-man. You can use OPH-man function equal to particular operator name you want to understand. Or if you want to show information about a primitive, you can use primitive name with function type primitive. This is the output of the OPH-man operator concerning, remember well, the merge OPH merge operator. So you can see an abstract description of the operator, and then the list of the arguments, the parameters you have to pass to the operator. And you can see also if an argument is mandatory or not. eventually with a default value defined. Some special arguments you can pass to the input stream, except mode if you want to specify that the execution will be synchronous or asynchronous. A number of codes or you want to use during the execution. Default is use only one. Session ID to specify your session, current working gear to specify the working directory, and the queue, so the input, the queue you want to manage, you want to manipulate. As for the others, you can use environment variables to set and to store this information of the each session ID, except mode, and so on. So, this is an example in asynchronous mode. So we can use OPH operator, except mode asynchronous, inside the terminal or also by the bash shell. In both cases, we have the output of the request with the job ID of your execution. This is a non-blocking request and no response will be rendered. In synchronous mode, with except mode sync, you have not only your request and your job ID, but also the response. So this is a blocking request, response rendered to standard out. So OPH provides many features to help the user to use Ophidia. One of these is the auto-completion. So using the tab key, you can auto-complete a specific command. You can use also this procedure to complete the environment variable, for example, of PH use to complete of PH user. Moreover, you can use tab to complete a specific app inside the file system.